Chemistry is a branch of physical science that studies the composition, structure, properties and change of matter. Chemistry deals with such topics as the properties of individual atoms, how atoms form chemical bonds to create chemical compounds, the interactions of substances through intermolecular forces that give matter its general properties, and the interactions between substances through chemical reactions to form different substances. Chemistry is sometimes called the central science because it bridges other natural sciences, including physics, geology and biology. For the differences between chemistry and physics, see comparison of chemistry and physics. Scholars disagree about the etymology of the word chemistry. The history of chemistry can be traced to alchemy, which had been practiced for several millennia in various parts of the world. Etymology. The word chemistry comes from the word alchemy, an earlier set of practices that encompassed elements of chemistry, metallurgy, philosophy, astrology, astronomy, mysticism and medicine. It is commonly thought of as the quest to turn lead or another common starting material into gold. Alchemy, which was practiced around 330, is the study of the composition of waters, movement, growth, embodying, disembodying, drawing the spirits from bodies and bonding the spirits within bodies. An alchemist was called a chemist in popular speech, and later the suffix -ry was added to this to describe the art of the chemist as chemistry. The word alchemy in turn is derived from the Arabic word alchemia. In origin, the term is borrowed from the Greek chi eta mu iota alpha or chi eta mu epsilon iota alpha. This may have Egyptian origins since alchemia is derived from the Greek chi eta mu iota alpha, which is in turn derived from the word shemi or kimi, which is the ancient name of Egypt in Egyptian. Alternately, alchemia may derive from chi eta mu epsilon iota alpha, meaning cast together. The term chemistry, in the view of noted scientist Robert Boyle in 1661, meant the subject of the material principles of mixed bodies. In 1663, the chemist Christopher Glaser described chemistry as a scientific art by which one learns to dissolve bodies and draw from them the different substances on their composition, and how to unite them again, and exalt them to a higher perfection. The 1730 definition of the word chemistry, as used by Georg Ernst Stahl, meant the art of resolving mixed, compound, or aggregate bodies into their principles, and of composing such bodies from those principles. In 1837, Jean-Baptiste Dumas considered the word chemistry to refer to the science concerned with the laws and effects of molecular forces. This definition further evolved until, in 1947, it came to mean the science of substances, their structure, their properties, and the reactions that change them into other substances, a characterization accepted by Linus Pauling. More recently, in 1998, Professor Raymond Chang broadened the definition of chemistry to mean the study of matter and the changes it undergoes. History. Early civilizations, such as the Egyptians, Babylonians, Indians amassed practical knowledge concerning the arts of metallurgy, pottery and dyes, but didn't develop a systematic theory. A basic chemical hypothesis first emerged in classical Greece with the theory of four elements as propounded definitively by Aristotle, stating that fire, air, earth and water were the fundamental elements from which everything is formed as a combination. Greek atomism dates back to 440 BC, arising in works by philosophers such as Democritus and Epicurus. In 50 BC, the Roman philosopher Lucretius expanded upon the theory in his book De Rerum Natura. Unlike modern concepts of science, Greek atomism was purely philosophical in nature, with little concern for empirical observations and no concern for chemical experiments. In the Hellenistic world, the art of alchemy first proliferated, mingling magic and occultism into the study of natural substances with the ultimate goal of transmuting elements into gold and discovering the elixir of eternal life. Alchemy was discovered and practiced widely throughout the Arab world after the Muslim conquests, and from there, diffused into medieval and Renaissance Europe through Latin translations. Chemistry as science under the influence of the new empirical methods propounded by Sir Francis Bacon and others, a group of chemists at Oxford, Robert Boyle, Robert Hooke and John Mayo, began to reshape the old alchemical traditions into a scientific discipline. Boyle in particular is regarded as the founding father of chemistry due to his most important work, the classic chemistry text The Skeptical Chimist, where the differentiation is made between the claims of alchemy and the empirical scientific discoveries of the new chemistry. He formulated Boyle's law, rejected the classical four elements, and proposed a mechanistic alternative of atoms and chemical reactions that could be subject to rigorous experiment. The theory of phlogiston was propounded by the German Georg Ernst Stahl in the early 18th century and was only overturned by the end of the century by the French chemist Antoine Lavoisier, the chemical analogue of Newton in physics, who did more than any other to establish the new science on proper theoretical footing, by elucidating the principle of conservation of mass and developing a new system of chemical nomenclature used to this day. Prior to his work, though, many important discoveries had been made, specifically relating to the nature of air, which was discovered to be composed of many different gases. The Scottish chemist Joseph Black and the Dutchman J. B. van Helmont discovered carbon dioxide, or what Black called fixed air, in 1754. Henry Cavendish discovered hydrogen and elucidated its properties, and Joseph Priestley and, independently, Carl Wilhelm Scheele isolated pure oxygen. English scientist John Dalton proposed the modern theory of atoms, that all substances are composed of indivisible atoms of matter and that different atoms have varying atomic weights. The development of the electrochemical theory of chemical combinations occurred in the early 19th century as the result of the work of two scientists, in particular, J. Baselius and Humphrey Davy, made possible by the prior invention of the voltaic pile by Alessandro Volta. Davy discovered 9 new elements including the alkali metals by extracting them from their oxides with electric current. British William Prout first proposed ordering all the elements by their atomic weight, as all atoms had a weight that was an exact multiple of the atomic weight of hydrogen. J.A.R. Newland devised an early table of elements, which was then developed into the modern periodic table of elements in the 1860s by Dmitri Mendeleev and independently by several other scientists, including Julius Lothar Meyer. The inert gases, later called the noble gases, were discovered by William Ramsay in collaboration with Lord Rayleigh at the end of the century, thereby filling in the basic structure of the table. Organic chemistry was developed by Justus von Liebig and others, following Friedrich Wöhler's synthesis of urea, which proved that living organisms were, in theory, reducible to chemistry. Other crucial 19th-century advances were an understanding of valence bonding and the application of thermodynamics to chemistry. Chemical structure. At the turn of the 20th century, the theoretical underpinnings of chemistry were finally understood due to a series of remarkable discoveries that succeeded in probing and discovering the very nature of the internal structure of atoms. In 1897, J. Thomson of Cambridge University discovered the electron, and soon after the French scientist Becquerel, as well as the couple Pierre and Marie Curie, investigated the phenomenon of radioactivity. In a series of pioneering, scattering experiments, Ernest Rutherford at the University of Manchester discovered the internal structure of the atom in the existence of the proton, classified and explained the different types of radioactivity, and successfully transmuted the first element by bombarding nitrogen with alpha particles. His work on atomic structure was improved on by his students, the Danish physicists Niels Bohr and Henry Moseley. The electronic theory of chemical bonds and molecular orbitals was developed by the American scientists Linus Pauling and Gilbert N. Lewis. The year 2011 was declared by the United Nations as the International Year of Chemistry. It was an initiative of the International Union of Pure and Applied Chemistry, and of the United Nations Educational, Scientific, and Cultural Organization, and involves chemical societies, academics, and institutions worldwide, and relied on individual initiatives to organize local and regional activities.